Thank you so much for coming, and I will do my best to keep you awake, but we might do an exercise sometimes in the middle of the talk if I see you starting asleep. So don't get sort of surprised. Certainly you need to stand up and do some wavings. Right, so I'm Natalia, and that's my talk, Observability at Scale. So a tiny bit about me. Who I am, I'm a developer, a consultant at Erlang Solutions. So just a quick thing. So in the next 2 slides, I will say about Erlang quite a lot. But it doesn't mean that the talk is about actually Erlang. I will talk about concepts that are quite widely used. I hope you'll find them useful in your code. But just to sort of get an idea, who work with Erlang here? Do we have Erlang developers here? Okay, 1, fantastic. Did you hear about Erlang at least? Good, oh, fantastic. So you know about Erlang, and that's beautiful. Right, so I'm a consultant. I'm also a researcher. I used to be a lecturer before, and I worked at Glasgow University. I still keep quite tight sort of connection with the universities. I co-supervise students. I'm a chair of the embedded working group. So in Erlang, if you're interested, do join. That's a really nice place to be if you want to work with Erlang, if you want to learn about it. Embedded, all sorts of things. My passion are robots. So if that's your passion as well, do join. And steering committee chair. So this is called Erlang Workshop, but actually we accept all sorts of papers about functional programming, about scaling, about all sorts of things. So if you're interested in writing papers, do reach me as well. So another thing is a little bit about the company I work at, just to give you an idea where the expertise, where the knowledge comes from, because this talk is not only my knowledge, but knowledge of my colleagues. So it's Erlang Solutions, 24 plus years of working, consulting companies, in particular with Erlang, Elixir, and AnyBeam languages. Also, any consultancy on scalability. Quite a lot of experts, 140 experts, working really high class. It's a pleasure working with them. And it's all sorts of support that we provide. So from very small, like a review of the code, to actually quite long support for 7+ years, to company who just enjoy our service and don't want to switch to somewhere else. Right, so that was about me, about the company. Observability, the reason we are here. So observability is, so the first thing is, why do we need it? Well, the reason is that we want to know our system. We want to understand it, right? We don't want it to be like lines of code or black box. We want it to be like the real system we can understand, we want to see what's happening. We want to have a plan, right? So if we see how our system behaves, what the latencies are, what the throughputs are, how many messages, how many processes we have in the system, how many clients, and so on, we can actually plan. We can plan our work, and we can do things. We also, when we understand our system, we have control. So it's not our system that controls us and tells, okay, 4 a.m. in the morning, get up, there is an error, go and fix it. It's us. We can see that there is an error, there is something coming, we need to be aware of it, and we can plan. And we work during the working hours, rather than wake up at 4 and then, or weekends, and do some work and support. And also, it's about being able to address issues promptly, right? So error happened, where did it happen? What happened? Why did it fail? We need to find all this information. And to be able to do that, we of course need observability. And then, when we start talking observability, there are these 2 things. People who never worked with it, or who had really good experience, that yes, observability is fantastic, because we can observe, we have all sorts of indicators, we can see trends, we get alarms on place, and everything works fine, and then we plan, we work, as we want, we have the design, perfect, life is good. But then, people sometimes listen to this talk and say, yes, I love observability, I love metrics and logs, I'll have them in my system. They go, they put everything in, and then a disaster happens, right? So what we hear, it actually slows down the system. So you said, I put metrics, I'll be able to plan, but now my system works slower than it used to. And then we have other problems like mess. The code becomes mess. When we work with it, it actually becomes useless, right? So we put all this effort, then we have this dirty code that we can't understand anymore, and when the problem comes, we actually can't use any of that. We can't use metrics, we can't use logs, nothing works. And after that, it's really difficult to justify. So we need to speak to managers and say, look, we need this time, we need these metrics. Look, well, we have a deadline, we have lots of things that need to be done yesterday, so no, thank you, but no thank you. We have developers, well, we sort of need it, but again, deadlines, we need to do that. So today's talk will be about how to work with our logs. So first of all, we need to understand how to work with observability, So first of all, we need to understand what they are. And when we talk about observability, we actually mean logs, metrics, and alarms. And when we talk about logs, this is something that already happened, right? We can't do anything about it. That happened, that's recorded. But they're useful when we start debugging things. That's our sort of information, what happened there. Metrics is about what's happening now. It doesn't mean that we can't go back to our metrics and see what happened like last week or a few days ago. We can, but the main treasure, the main benefits of metrics is that we look what's going on with our system now at this moment. And finally, alarms, and they're about future, right? Something is going to happen, and alarms tell us, be prepared, right? This is the trend, that we hit something, just be ready for that. So this talk will be all about how we design our observability, how we design all these logs, metrics, alarms, how we work with them, what's important. And one thing I would like to tell you is that design is hard, but it doesn't mean that you shouldn't do it, or you should get some external company, some consultancy to do it for you. No. But what I mean here is that you need to allocate time, you need to allocate resources to make it right. Otherwise, it just become another waste of time. So we'll start with logs. So what is logging? When we talk about logs, we actually talk about two types of logs. We talk about failure and errors logs. So there was an error, something happened in our system, and we recorded that. But apart from that, we also have audit logs, and they are application specific. So for example, it's easiest to understand when we talk about fintech, right? So a client, think about a bank, client requested 10 pounds or 20 euros and collected them from the cashing machine, for example. We need a record that it was successful, that the money left. Otherwise, we can get into trouble. So there are lots of sort of audit logs for regulatory purposes. For example, when you work with different teams, you want to protect yourself, so you need to have these audit logs so that you know that this event happened and you're sort of covered for all sorts of reasons. So this is just a quick look. So what logs are, how they look. And you can think, of course, you all saw logs, and they're like huge gigabytes of terabytes of data. And the reason I put it in here is that you're not expected to look at them every day. You store them, maybe you have some application that does something for you with them, but actually you're not supposed to look at them every day. You just know that they're collected, and when something happens, you can go and retrieve them. So when we talk about logging at scale, one of the best things that we can do is documentation. But when I say documentation, it doesn't mean that we take every log and we record them sort of separately in a Word document, a Google document, or whatever document. What we can do, we can record them in our code. We can have something, a template, where for each log, we record a couple of things. And here what we need to remember is that logs should all have identifiers and should all have a single identifier. So each log should have an identifier. And the reason for that, if you start combining them, what will happen is that another failure happened, you've got an ID, And then good luck to guess which one that was, right? Especially when you're pressed on time, you don't have access to repeating the error. Well, that's the last thing that you want. So what you want for each log to have its ID so that later you can quickly pinpoint where that happened. Another good thing is to have some kind of application, to have some kind of barrier between your code and the third-party log tool that you're going to use. So what does it mean? Think about scale, right? Your big code. And then you started putting your logs everywhere and using the tools. And at some point you decided, well, actually, there is a much better tool out there, right? Should I use something else? And then because it's everywhere, good luck getting a permission to change that code. Too much code change, nobody's going to allow you, so you are stuck with that. Right? So what is the best approach is to introduce this internal API, where inside your code, you only use your API, and that module application, depending on your language, whatever you use, that's where you sort of interface with your application. And then you can change it pretty quickly. Code change is going to be approved because it's just a single app. It's isolated. You're not touching the whole one. So it's going to be much faster. So that's the other thing. We talk about levels. And here there are warnings, for example, errors, info, all sorts of things. What you want to do is to channel them into different, right? So for example, error, that's the highest level. And you want to make sure that errors are all come through quickly. You don't want them to get stuck in the info, just general information that can be recorded later, right? So that's very important. Severity, I actually put it just to give you an idea that it can be anything. You can have any information you find useful, and it doesn't have to be something very rigid one. If you find that within the errors, you have different severity, and it will be helpful for you, do have it. Another thing is log message. So think about log messages. They should be quite short, because what you don't want is that you start going and searching for that log, right? Or you start searching for information, and then where is it, right? And if the text messages are really long, that's a bad service to you and to other developers that you work with. And it's going to take lots of time to absorb the code, understand what's happening. So when you write those messages, try to be prompt, not, don't composing really nice, beautiful sentences. Think that you're going to use it, so they should be really short. They should contain some information from your code, but not too much. So keep a balance here. And again, when I say not too much, and the next question comes, but what is not too much, right? How do I know? That's experience, right? Start using them, introduce information, use your logs, and you'll find that balance just through the experience, right? But yeah, it depends. Sometimes you don't need any additional information. The next thing is impact. And here, you can talk about like what happens after the error occurs, right? Because the error happened, but we might not realize what's happening next. So it's a good prompt to other developers what's happening. Another thing you can add is a reason, is a resolution. So for example, you're coding really fast, and you don't have time to deal with that error at the moment. So maybe later, you will have time, right? And you know the solution, what you need to do, so it's a good place to put what I would like to do later. Right, so let's go and look at the issues that we may face. So one issue, well, we added logs and they're not actually usable. So what do? We design them, right? So when we design our logs, we don't throw them at our system. We don't sprinkle them. We design them, right? We think carefully why we need those logs. And ideal solution is you start with your system and you start with your logs. From the very beginning, you have them. That's an ideal life. We often don't have that luxury, so we already have the code and then we work with it. So what we do, we gradually introduce it, right? So you got your code, don't try to add logs everywhere. You work with the code, you understand where the logs need to be, just add it gradually, don't rush. Follow patterns and then that we discuss, and then don't confuse logs with debugging. So debugging, we resolve a particular issue, we may add debug logs, we may find the issue, and then we remove all those debug logs. It's not a good idea to keep it. The reason is that when you start going through the logs, it's going to be a disaster, right? There will be too much repeated information, really slows you down, so just don't do that. You have your logs, work with them, you don't need them, remove them after that. Think about the logs, how sufficient is information there. Do we have sufficient information? Do we need to add something? Do we need to remove something? Do it an iterative process. Next thing, they create lots of mess. Well, if they create lots of mess, do the documentation, right? Don't overload logs. So again, one log, one ID, don't use too many so that your log doesn't carry the errors from different places, even if you think that the error is the same, right? There might be different reasons, but even if the reasons are the same, still separate them, so it's easier to pinpoint the problem. And of course, separation of concerns, right? So your code is in one place, and the sort of logs in another place, and another one is different types of errors need to go in different files. Don't push them into the same place. Right, they cause failures. So revise your logs, right? So logs is not something that you just sprinkle and then they should automatically evolve themselves as your application changes. So make sure that you treat them and you give them the needed respect they deserve, right? This is the code, this is important code, allocate sufficient resources to deal with them. Metrics. So now we'll talk about metrics. What is metrics? Metrics are performance indicators. And when I talk about metrics, I always like to use the airplane cockpit example. Right? So very often what I hear is that people switch off their metrics for the live systems. And here, let's think about a plane. Right? So we have all these beautiful indicators, right? So the pilot is on the ground, everything blinking, everything is switching on, everything is beautiful, passengers are loading, boom, we switch everything off, and here you go, enjoy, right? So that's not a particularly where we feel the best. So metrics, I'm not saying that you shouldn't use metrics during the testing. Obviously you should. But the main value of the metrics come during the live system. When a system is actually working, performing, when you actually observe what's happening, that's where the value comes from. And metrics, they all show you the performance, what's happening in the system. This is just a couple of metrics sort of pictures, just to give you an idea. Some people haven't seen metrics before, so how they look like, right? So this is from Phoenix application. It's a Elixir application, and here we have some information, like, for example, binaries, how much space take, how many inputs, how many atoms we have, and so on, ports. We can have some information about our system, so how many a particular request, for example, takes, long, short, what's happening with it, and so on. And finally, we can have some information about the processes. So this is just to show you what metrics are. Of course, you have different languages, you have different tools, so this will vary, and the beauty of the pictures will also vary, but essentially, that's what we expect from the metrics. The thing that we need to remember about metrics is that they're not free. So metrics are collected at the points where a system works perfectly, right? So when we talk about logs, especially error and failure logs, they happen when a failure occurred already, right? So usually it already takes lots of time to recover from that failure, so we don't take much time, we don't care much how long it takes. But when we talk about metrics, they're happening all the time at the places where our system works beautifully. And by adding metrics, we always interrupt it. We can interrupt it for a tiny bit, we can interrupt it for a lot, but there is always an interruption, there is always an overhead that we need to remember. So the thing is that, and this comes also from a client, once they said, we want a zero overhead metrics, right? So there is no such thing. Will also be overhead. What you can do is to minimize them, but they'll always be there. So what you can do, know your tools, know the tools you're using, know how much they take to collect the metrics. That's really, really important. Collect only what you need. So if you don't need a particular metric, just take it away. Remember, it's all the time, it slows down your system, so keep only things that you really need. And of course, keep your code clean. This will cleaning the code, or removing the metrics that you don't need anymore is always helpful. So, for example, you investigate something, right? And you will put lots and lots of metrics in that place. Then the problem is resolved. There is no bottleneck there anymore. So we can take almost all metrics out and leave only a few ones there. When we work with metrics, especially for developers, we need to understand that there are different types of metrics. There are different types of stakeholders who need those metrics. So when you talk about types of metrics, actually, I put 3, but there are actually as many metrics, types of metrics, as stakeholders there are in your project. If there are 2 stakeholders, right, so developers and the business manager, there are 2. If there are more, so sales, UI, all sorts of people, the more sort of types of metrics you add. And the people who care about the metrics should be the ones saying what should be added. So for example, if you are a back-end developer and you add metrics for sales, it's not you who decide what metrics should be there, it's them. Right? They should tell you what they're interested in. Of course, you can prompt them, but actually, it's their decision. So we'll look at 3. We'll look at business, product, and systems. We'll start with the systems one, because these are the ones which are close to the sort of my heart and backend developers in general, right? So what we have here is monitoring performance, and also most of the time, we look at performance, reliability, availability, this kind of parameters. So first of all, we look at the host. So our applications runs on a host. We want to know as much as possible about that host. CPU, memory, disk, available space, processes, whatever that is, threads, whatever your language is, right? So what's happening with the host that serves our virtual machine or our system. The next thing is your application, the one that you're actually working on, and that's everything inside it. So rate of error and success, right? Any service failures, something is not communicating within the application, I'm not talking about network here, something is not working correctly within your application, that's all we want to record. Something works exactly as it should, we may want to record that as well. All sorts of rates, all sorts of interactions within your application. Network connectivity, you have more than one host working in your system, you may want to monitor the network, right? Are there disconnections? Some node maybe fails more often than the rest. So we want to know what's happening in our network there. And finally, external dependencies, right? That's a really important one, especially if we pay huge amount of money for their services. We need to know when they disconnect, how they don't work. When we talk about third parties, we also may think about services provided by other teams, right? So if the work of other team jeopardize our performance of our little bit, that's something we want to sort of monitor and make sure that that is resolved. Right, when we talk about system metrics, right, how do we start with them? So my suggestion is always starting from the bigger picture. Don't try to add all the metrics, all the parameters that you decided that you want to have in your system, right? So for example, you have some application and you've designed it and you know what you want to do. and you have like 200 or 300 metrics, right? So next step, what do? We add all of them. Well, actually, no. We add 12, 15, just to see what's happening. What we use a spiral approach. We add them, we see what's going on, we add more, we observe what's going on, maybe take something out, we don't need that anymore, and we always work with spiral, right? We clean, we add, we clean, we add, all the time. Another thing, when you add your metrics, have a clear understanding, why do you do this? Do you want to scale? Do you have some kind of performance improvement? Why do you add these metrics? What do you want to know about your system? And actually, this is a really good approach when you work with metrics. Understanding how your system works and predicting this for yourself. Because if you have this question in advance, like for example, you haven't seen it yet, and you say, I think it should go constantly, up. Or I think it should stay level, or it should go up and down, and then stay there. As soon as you see the metrics, you can understand whether your system works as you expected or you don't understand your system. Because at the time you see the picture, that's too late, right? You already have the data, you can adjust your brain to sort of fit how it works. But when you have this sort of mismatch or match, you actually understand your system much better. So when we talk about product metrics, it's all about product, and it's all about making better product decisions, right? So these are people who care about the product as a whole, not as a sort of separate bits of it, as we, for example, developers care about. There are different approaches that they may use. So example is I used here is pirate metrics, but it's actually whatever they want. And your job here is just to sort of show them, like, that's what we can do, or we can do this, or we can do that, so whatever you like. So the pirate is sort of looks at the acquisition, right? So we've got a client. We sort of what types of action, how many actions they do. They come back, retention, so how many times they come back. Revenue, so do they go to paying, for example, for their services, so they don't go for their services. And then referral, do they actually refer your product to another customer? Do they introduce somebody else? So it's all about that. When we talk about indicators and product metrics, we can also often hear leading and lagging metrics, right? So leading is something that drives daily. That's a very short, we can check them very quickly within our within a sprint, right? And see and do the changes. The lagging one are the long term. So for example, we want to have more customers, right? That's the lagging game, lagging indicator, right? That's a long term. And then to achieve that, you do very little small changes every day to achieve that. And then, with the leading, you can see whether you achieved that goal today, tomorrow, and every day. And with the lagging, is after a year, is it working or not for you? And finally, business metrics. So these are metrics in interest of a business manager, marketing, sales, all sorts of people, organization goal, some kind of compliances, alignments, sort of long-term goals. For example, they want to check yearly how many every year they have clients, new clients, how many daily users they have, all this information. So this comes from the business metrics. This is all for your information, just in case you will need to work with people there. Right, so problems, right? So we want to add metrics, but manager doesn't want to add them, so what should we do? The easiest way is to start adding metrics interested to the budget holder. I would call them like that, right? So not ask maybe you can ask, but often you can guess what they need and start adding metrics for those people. And then suddenly you will realize that they're very excited about those metrics. And the reason for that is that for business people, for managers, very often the code is a black box. They don't understand it. They don't know how it works. For them, just a box, it does something, so they don't have interaction much with it. But when they get metrics, it's like it's a living thing now. They can see it sort of breathe, they can see it live, they can interact it, they can make decisions. Suddenly they get excited about it. And if they get excited about their metrics, they will be more sort of kind and lingering towards allowing you to have your own metrics as well. For ourselves, can it find time to work with metrics? Well, let's be honest with ourselves. Do you actually want all those things, right? Or do you want to look for excuses? Do you like to work over the weekends? Do you like to wake up? Do you want to be thrown errors? Do you like to see results of your work? There are some people who are hackers in their heart, right? They don't want that. They don't want to plan. They like wake up in the morning and feeling that they're really needed in this company and they can sort things very quickly, whatever that is. And that's you. Well, just accept it, say it loudly, and then you don't need metrics. But if you're not one of those people, if you want to plan, if you want to sleep, if you want to do other things than your job, if you have another life after work, that I strongly encourage you to stop finding excuses for yourself and start adding metrics and find time for that. So impossible to change tools. So the best way is separation, right? You've got your code. There should be no tools in there, right? There should be only code that you wrote in your own code. Even by your code, I mean there shouldn't be tools in your code. So you have this application separation, and that separated code, your own API, you add in your code, and then you work with that. Then it becomes really easy to change that. Keep it clean, right? So we have code becomes messy. Again, metrics are not used to remove them, only what's needed. Here, we really need documentation, right? For metrics, it's very difficult to sort of have this separation. In one place, we have code, in another place, and from the code, we can extract metrics. Strongly encourage you to have a full documentation and description, what sort of metrics, different tables for different stakeholders, keeping, updating that information, making sure that you can do that. As actually, after you design metrics, when you properly design them, it's really easy to take care of them. You can give this job to a junior. And sometimes people misunderstood me when I say give it to juniors. I'm not saying give the juniors to power to decide which metrics should go in and which metrics should go out. That's not their job. It should be done by the stakeholders. It should be done by tech leads, right? And senior developers who were already burnt and cut and suffered from bad metrics, right? For juniors, it's a really good exercise with taking care of something, be clean and tidy with the code, and really taking ownership that everything is clean and nice inside. Metrics slow down the system, redesign your system. Redesign your metrics, I'm sorry. Keep your system, redesign your metrics. There was an error there. Something is not working for you, right? Look at the things, know the costs, know the resources that you use. For example, usually we care about time, right? But if we care about time, we can spare memory. If you can't spare memory and time, it means your system is already in a very bad position, right? There is no margin for errors. So think what you can have. If you really care about timing, that ensure that there is a plenty of memory that you can use for your metrics, right? If you really care about memory, then you can spare the time. But you always need to think that something needs to be spared here. And the best way is taking your metrics outside. So for example, in Erlang, we would say taking it out of your process so it doesn't slow down, taking it out as much as possible, right? So like, for example, I'll give you an example of numbers. For example, in Erlang, to take a timestamp takes around 25 microseconds, right? A timestamp, 25 microseconds. And then, if you measure something that takes, say, a millisecond, that's fine, right? Just an error. You can just periodically just increase it by 25 microseconds, that's fine. But if you measure something that takes nanoseconds, right? Say 100 nanoseconds, well, then you are slowing down your system so dramatically that it just won't work for you anymore. So understand your system, know how long it takes to collect your data. And then design it for redesigning. So your metrics like your system. So you built your system, but you know that your system will grow, it will change, and you plan for redesigning it. The same with metrics. You build them, you edit them, your system changes, your metrics need to be changed. So make sure that your design includes the changes. I'll actually repeat this phrase quite a number of times now. Redesigning. So metrics don't work at scale, redesign. So you built your system, and it was for a particular scale, and then the system grew, and it doesn't work for you anymore. So you need to redesign. The same is with metrics. You built it for a certain scale, you grew, it doesn't work anymore, just redesign. And then they don't provide the benefits, again, redesign. And then look at the causes, what's happening, why that maybe you're not clear what to improve, right? So one of the things is we have so many metrics that we want to improve. There are so many of them, we don't know where to look, or you don't have a habit. So with metrics, you really need to have this habit where you look at them every day, for example, or once a week. So you're really familiar with the system, so you know how to change your system at all times, and you don't have anything that is sort of blurs that vision. So this is a small example, just to give you an idea how I would design that, right? So you developed a project locally. It runs lovely. Everything is great, perfect. When you deploy it, it runs significantly slower. So what we do, we think that the problem is X, and we are going to work on X. Well, the thing is that you don't know that the problem is in X. So the best approach is to add metrics, right? Not many, just to get a sense what's happening, right? I would recommend to add 10, 15 metrics there in different areas, but just so your timing, it takes the whole thing, like you can add them. And then where you think the problem is, just add a little bit more metrics. And then you will see if the problem is there. So the reason I'm saying it is that you can think probably yourself how many times it was that you thought that the problem is X and it's not there. You're fixing, you're improving, you're doing it, it's not working. You go to another place, you think it's there, now we're fixing there, it's not working again, right? So it's lots of wasted time. So instead of investing, working frantically to fix something that's probably is not a bottleneck, invest the time in adding metrics. We had that a couple of times. We work in parallel, so I would add metrics, and another guy would work on solving a problem that he thinks that the problem is, right? Just because we had resources, the client wanted that. And there were a few times when, by the time I completed my metrics and we did the measurements, we were clear that the problem is in the wrong place, right? So his effort was wasted. In that particular case, it wasn't wasted because if he would hit the problem, that would be fantastic, but sometimes it's not the case. So it's better to save your resources if you can, and then just spend them on understanding your system. So, and last bit is alarms. So when we talk about alarms, we can have them alongside logs. So for example, you go, and you say, if this happens, we want to raise the alarm. Or you can have them for metrics, and then how you add them really depends on your tools, right? So your tool may say, okay, if we go beyond this point, then we raise the alarm. So that's how it works. the things with alarms, you need to be really careful. They sound amazing, right? When a problem comes, we raise an alarm and we get notified, everything is great. Well, in reality, you actually need to know this sweet spot. And to know the sweet spot, you need to understand your system, you need to work with it, right? You raise alarm too early, and they get raised very often, like every time. And the worst, what you can do with alarms, you can start ignoring them. And that's the problem, because at this point, as soon as you start ignoring an alarm, it's easier just to remove it, right? Because it's just an illusion that alarm is there. Actually, it's not working for you anymore. It's too late, right? So, well, the system is already crashing. What can you do? So what's the point of the alarm? So the good solution is introduce them in stages, right? So if, for example, the critical point is memory at 85, start introducing it a little bit earlier. But again, look at your system, right? Maybe for you, the critical is when memory is 40%, right? And usually it must be quite low. So for you, 40 is already, it means it's rising rapidly, and you need to act faster. So introduce them a bit earlier than that. Ignoring alarms, we talked about, yes, and priority. So another thing, what you don't want is the alarm stuck somewhere in the queue and waits when other less important messages get through. So dedicated channel, dedicated queue, whatever that is, make sure that you get alarms really, really fast. So takeaway is design is the key, right? Don't sprinkle, don't throw, design. Doesn't work, redesign. So most often is if metrics don't work for you, it means that metrics design doesn't fit to the design of your system. So that needs to be worked. And that's it. Thank you so much for staying. Thank you so much for listening.